Hello guys. Actually, from 49 to 61, I have actually done these things and I have recorded one video. But in that video, the audio is not clear. That's why I have solved the question here. I am just explaining you the things and the answers. Okay. So from 49, there are three or four things. Like from 49 to 52, there is modern physics question. From 52 to 54, there is nuclear physics question. From 54 to 57, there is quantum mechanics question, and from 58 to 61, there is thermodynamics question. So we will solve this question in this video. So the product of group velocity and phase velocity of a relativistic particle is, so basically phase velocity is equal to how much? W by k, which is equal to E by P. Group velocity is how much? dw by dk, which is equal to dE by dP. Now in case of relativistic thing, we will use the formula E by P and dE by dP. What? Why? Because we know the formula for relativistic thing is what? E equal to P square C square plus M naught square C to the power 4 root over. So using that, we can have group velocity equal to dE by dP, which is equal to, just derive this thing and you will get Pc square by E. Now the product of group and phase velocity. Now group velocity we have derived Pc square by E, and phase velocity we have E by P. So just multiply, you will get C square. So C square is the answer. Next, 50. If a particle of mass 3m is at rest and decays into two particles of mass m and 2m with non-zero velocities, then the ratio of the de Broglie wavelength of the particles of mass m and 2m is. So here a 3m, which is a rest particle, decays into what? M and 2m. So 3m has velocity 0, that is it is in rest, but m and 2m has non-zero velocity. Let the velocity of m is vm and the velocity of v is 2m is v2m. Now it is asked about lambda m by lambda 2m. For that, we know lambda equal to what? H by p. So it is equal to h by mv. Okay. Now in order to find lambda m by lambda 2m, we have to know the value of v for both masses, that is m and 2m. Now for that, we will calculate vm and v2m or their relation. For that, we will use the conservation of momentum. So according to conservation of momentum, P initial equal to P final. Now P initial, in this case, P initial, that is momentum of that 3m mass thing is what? 0, because it is at rest. So P initial equal to 0 and P final equal to Pm plus P2m. So P2m equal to minus Pm. So their magnitude P2m equal to Pm. Next, momentum is what? Mass into velocity. Here mass is what? 2m, velocity is v2m. Here mass is m, velocity is vm. So v2m divided by vm, we got 1 by 2. Now lambda n by lambda 2m is equal to what? H by mvm plus h by, so divided by h by 2m v2m. So it will be what? 2m v2m divided by m by vm. M into Vm. So 2 into V2M by Vm, which is nothing but half. So 2 into half equal to 1. So the answer will be 1. <clears throat> 51, I guess. Yes, 51. Next is 51. If difference between nth and n plus 1th Bohr's radius of hydrogen atom is equal to its n minus 1th Bohr radius, then the value of n. So basically, it is given Rn plus 1 minus Rn equal to Rn minus 1. For that, you have to first know what is Rn. Now, Rn in what? Hydrogen atom spectrum is equal to, according to Bohr's theory, equal to A0 n square by j. Okay. Where A0 is the first Bohr radius, whose value is 0.53 angstrom. I am not saying about those things more. So basically now for hydrogen atom, Z equal to 1. So Rn equal to A0 n square. Now Rn plus 1 equal to what? A0 n plus 1 whole square. Similarly Rn equal to A0 n square. Rn minus 1 equal to A0 n minus 1 whole square. Now it will be n plus 1 whole square minus n square equal to n minus 1 whole square. Now just we are just solving this n plus 1 whole square minus n minus 1 whole square equal to n square. Now a plus b whole square minus a minus b whole square equal to 4ab. So 4 into n into 1 equal to n square. Now n square equal to 4n, so n equal to 4. So the answer will be 4. Next, nuclear physics started. If mass number of a nucleus is A, then the Coulomb energy term EC in Weizsäcker mass formula is related to A as. So this is basically nothing but semi-empirical mass formula which is derived from liquid drop model. So the Coulomb energy for semi-empirical mass formula is EC equal to minus AC Z whole into Z minus 1 divided by A to the power 1 by 3. So basically EC will be proportional to 1 by A to the power 1 by 3. If you don't know this thing, just know this thing. Coulomb energy is nothing but 1 by 4 pi epsilon naught Q1 into Q2 by R. Here that is E is proportional to 1 by N. Now R is proportional to A to the power 1 by 3. So E will be proportional to 1 by A to the power 1 by 3. If you don't know the semi-empirical mass formula, you can answer it by using common sense of Coulomb energy and Coulomb force things. Next 53. If the half-life of radioactive decay is x times its mean length, then x equal to. For that, you have to first know T half. T half is the half-life. Half-life equal to ln 2 by lambda, which is equal to 0.693 divided by lambda. Now, mean life tau equal to 1 by lambda. So, T half equal to 0.693 into tau. So, basically, half-life will be 0.693 times of mean life. So, answer is B. Now, quantum mechanics question started. 54. For wave function psi x equal to n e to the power minus x square by 2, normalization constant n is. So, in order to find the normalization constant, you have to use the normalization condition, which is equal to psi star x psi x dx integration is equal to 1. Now, as there is no limit given, so we will use the full limit, that is minus infinite to plus infinite. Using this, we will solve. Okay. So basically, now psi x equal to this, then psi star x equal to what? Same, because there is no complex term. So psi star is equal to also n e to the power minus x square by 2. So it will be what? N square into e to the power minus x square dx integration. Okay. Now in order to solve this, we solve it as we change the limit minus infinite to 0 to infinite. How? Here e to the power minus x square is a even function. So even limits becomes 2 into 0 to e to the power 2 into integration 0 to infinite. If it was a if it was a odd function, then the integration will be 0. As this is a even function, so this integration is converted to this only. Next, we will solve this integration. We will solve this integration using what? Gamma function formula. From gamma function, we have a formula x to the power m minus 1 e to the power minus a x to the power n dx integration 0 to infinity is equal to 1 by n gamma m by n divided by a to the power m by n. Here in the integration m equal to 1, so 1 minus 1 0, so there is no x. N equal to 2 and a equal to 1. So use this formula, it will be 1 by 2 gamma half divided by 1. So it will be root 2 pi by 2. So use this 2n square whole into root 2 pi by 2 equal to 1. So n square equal to 1 by under root pi. So it will be 1 by pi whole to the power 1 by 4. So this is the answer, 1 by pi whole to the power 1 by 4. So this is the general general procedure in order to find the normalization constant. But since it is a Gaussian function, there is a shortcut formula. I don't know whether you know about the Gaussian function or not, but for the Gaussian function is what? Which can be written as n into e to the power minus a x minus x naught whole square. This is basically the Gaussian function. For Gaussian function, the shortcut formula for normalization constant is equal to 2 by pi coefficient of x minus x naught whole square whole to the power 1 by 4. So using that also you can find, but the general procedure is this, that is using the normalization condition and solving the integral. Next is 55. The expectation value of px for the wave function psi x equal to 2 by L this sin pi x by L for 0 to L psi x equal to 0. So basically this is a what? This is a wave function for one-dimensional rigid box. For that, you know the expectation value of px is nothing but 0. This is a direct thing. Expectation value of px equal to 0. If you don't know, you at least know the expectation value of x for 1D rigid box equal to L by 2. Using that, okay, using that you can have what? The px value. How? Now using Ehrenfest theorem. Using Ehrenfest theorem, the average value of px is equal to m into d by dt of the average value of x. Now, average value of x is a constant, so derivative of that is 0. So the answer is 0. If you don't know anything in this, just use the general formula for finding the expectation value of a operator. So finding the expectation value of a operator can be what? Expectation value of operator let px cap is equal to integration of psi star x into px cap into psi x dx. Limit as given 0 to L. Now here psi x is what? 2 by L sin pi x by L. Okay, just use this and solve this. Where px cap is what? The operator is what? Minus ih got del by del x. Just use it and solve it. You will get the value as 0. So the answer is 0. Next, 56. If anyone don't want the explanation, just skip the video, get the answer and check it. And if you want, I will provide the answer keys, okay, in PDF form by the tick mark in the option. Okay. Next is 56. If the 0 point energy of one-dimensional harmonic oscillator is this, then the energy of second excited state is. So, basically the 0 point energy is nothing but the ground state energy. Okay, now for one-dimensional burst in nth excited state, the energy formula is En equal to n plus half whole into h cut omega. Now for ground state, n equal to 0, or which is called as 0 point energy, n equal to 0, so E0 equal to h cut omega by 2. Now it is asked about second excited state. Now for second excited state, n equal to 2, so E2 equal to 2 plus half whole into h cut omega equal, which is equal to 5 by 2 h cut omega. Now the relation between E2 and E0 equal to E2 equal to 5 E0, which is equal to 5 into 5.25 into 10 to the power minus 7. Now by solving it, you will get 26.25 into 10 to the power minus 7. So the answer is D. Next, the change in kinetic energy due to Lärmos precession in case of an electron orbiting in magnetic field B. So, basically, if anything asked about the energy formula due to Lärmos precession or due to spin orbit coupling or due to anything, the basic formula for energy is equal to minus mu bar dot B bar, where mu bar is what? Magnetic dipole moment and B bar is the magnetic field. Now, the formula for magnetic dipole moment is E by 2m into L bar. Okay. And the magnetic field is B bar. Now the magnitude of mu bar equal to EL by 2m. The magnitude of B bar equal to B. Now the magnitude of energy equal to what? Mu B. It will be EL by 2m into B. So the answer will be LBE by 2m. So the answer will be A. Next, thermodynamics. Now, what is it asked? 58. Choose the incorrect statement. Okay, let's read the options. Change of entropy in reversible process is 0. Yes, the change of entropy is greater than equal to 0. Now the change of entropy del S is 0 for del S of what? Total universe. Okay, is 0 for reversible process and del S is for universe is greater than 0 for irreversible process. Okay, so in the first option, the change of entropy reversible process 0. This is right. Next, it is asked about the incorrect statement. Don't choose the correct statement. Okay, next the option B, the change in entropy is path independent. Yes, the change of entropy is path independent but state dependent. Okay, while the work and the heat energy are path dependent. Okay, so basically entropy is path independent and state dependent. So this is also right. Next, in irreversible process, the total entropy of the system and the surrounding, that is system plus surrounding means universe, does not change. This is wrong because in irreversible process the change in entropy what is greater than 0. This means it is not constant. Okay, that is the entropy is not constant, that is change is not 0. So in irreversible process the entropy always increases. So the change is not. So there is change. Okay, so this is a wrong. This is wrong. So the answer will be C only. Okay. Let's read the option D also. The entropy can never decrease in any process. Here this is also right. You know, for For system plus surrounding, del S is always greater than 0, but never less than 0. So the entropy can never decrease for any process. So the answer will be what? The wrong answer will be C. Hence the incorrect statement is C. Next, 59. For 1 mole of fundamental gas, del U by del V is equal to. So basically this question is wrong. This is not del U by del V, but this is del U by del V at constant S. You see, it is given that constant T, but this is actually constant S. Now del U by del V at constant S. Now how can we get del U by del V at constant S? Now in thermodynamic potential we have studied the internal energy is function of entropy and volume, which can be written as du equal to TdS minus PdV using first and second law of thermodynamics. Now del U by del V, that is del U by del V at constant S. This means this term will be get 0 is equal to what? Minus P. Yes, we will know that. Now in order to find del U by del V at constant S, we have to find P. Okay. Now we know the van der Waals equation of state for 1 mole is nothing but P plus A by V square whole into V minus B equal to RT. Sorry, this is not nRT, this is RT. Okay. Now let's know this P value using dimensional analysis. Now you know if two things can be added, then their dimension must be same. Similarly, if two things can be subtracted, their dimension must be same. Okay, so here the dimension of A by V square is same as pressure, and the dimension of B is same as what? Volume. So let's match the dimension and know the answer. Now in the option there are 4 options: A by V square, AB, A by V cube. Now from these options the pressure matches with the option B. So the answer will be nothing but A by V square for pressure. Now pressure equal to A by V square, then obviously del U by del V at constant S will be what? A by V square. Next, most probable speed Cmp of gas molecule in absolute temperature T. So the most probable formula is what? 2 kT by m root over or under root 2 RT by capital M, where small h is mass and capital M is atomic mass. So basically most probable speed is directly proportional to under root T. Next, inversion temperature in Joule-Thomson effect in case of van der Waals gas. So inversion temperature is nothing but the Boyle's temperature, and the formula for Boyle's temperature is equal to what? A by RB. So the answer will be D. Thank you guys, and sorry for the inconvenience that I have solved this question in this video, but in the next video this will be not the issue. In front of you I will solve all the question and upload the video. In this video there is actually audio issue which I have recorded, so sorry for that.